And what focus in APM?
Strategy management.
What? Management. Okay. Okay, is that everybody? Yeah. Okay, good. So a lot of management people here and some other things as well. Okay. Well, anyway, another thing. How many people have studied calculus? Okay, well this should be a breeze for you. So, hope it not too boring. Okay, so we covered that. What else do we need to do? Okay, let's, anybody have any questions? Yes, sir.
What is the failure percentage in this class?
What is the failure percentage, what?
In this class.
I mean, what do you mean? What will cause you to fail? I mean, what, how many?
Every semester, what percentage of people...
Oh, I see. About 20. Yeah. But I hope it's a 0 this time. So you know all the homework, you know the final exam, you know the midterm. So you have the AMC, that's the tutoring center across the next building over there, which is open from 3rd to 6th period, and you should use it if you have any trouble. Okay, don't wait. Use it. It's first, as the doctors say, at the first sign of a cold, you should, what do they say? I don't know. You should take aspirin or something, right? At the first sign of not understanding what we're talking about, you should figure it out. Either figure it out on your own or go to the tutoring center and figure it out. Okay, don't let it go beyond that. Okay? Now what else? Okay, so let me find my PowerPoints. So I have to figure out how to give these to you. But let me just download those. So our first few classes are going to be in up to finance. So, but let's start with the very first lecture. Functions and applications. Okay. Okay, so the concept, most important, the word that you'll probably, if we counted the frequency of words that are spoken in our class, probably the math word that will speak more than any other word is the word function. So we need to know what function means. Okay? So basically a function is like a relationship. So what is a relationship? What does that mean? So, think of the ways you can use the word relationship or sentences that you can make up using the word relationship. Right? So one way you can say is, I have a relationship with my father. Right? I'm my father's son, and my father is my father. Right? So that's one way to use the word relationship. Okay, or I have a relationship with, if I'm a guy, I might have a relationship with a woman, or vice versa, or whatever, right? I have a relationship with my friend, right? So on. We can say those are some of the ways we can form sentences that have the word relationship in them. What other, can you form another sentence besides those where you use the word relationship? Yeah.
I would imagine in mathematical terms,
right.
Can we say reciprocal effect?
Okay, what do you mean?
When one thing changes, another changes too.
Okay, right. So give me, like, yeah, that's exactly right, but give me a concrete, I mean a specific, use the word relationship in a sentence. Anyway, before you do that, he just said, what did you say? The relationship, when one thing changes, another thing changes, right? So there's two things, right, that are therefore related, right? So there's two things. So one thing, when we talk about relationship, we're talking about like there's two parts, right? Two things involved. Okay, but still, what's a sentence? Or anybody else, what's a sentence? With the word relationship. Anything you've come across in your, heard in the news or anything, yeah?
Something like related variables
Okay, yeah, that's right.
have a tight relationship.
Okay, good. But I want like a really, like something you heard in the news. They don't usually talk about it. It's quite sad. You won't really hear that sentence in the news. Yeah.
Two variables which has common interest.
Two variables that have common interest. Okay. But I don't think I've heard that in the news recently. There are two variables that have common interest. I didn't hear that on the local news, on the nightly news recently. Something more typical, more common. Okay, how about, how about the relationship, this is not the example I wanted, but the relationship between the United States and Japan has gotten worse in the last year, or something like that. Okay, that's another example, but that's not actually what I'm trying to think of, but, okay?
As the time passes, Japanese economy rises.
Okay, good, that's good. So, so what are the two things that he just mentioned?
The relationship of time and Japan.
Time and the economy, right? So he's relating time to economy. Now, economy is not very clearly defined, right? What do you mean? You mean GDP, or do you mean something else? It doesn't matter, right? We're not worried about that, but could be lots of different things. But anyway, something like GDP, or could be exchange rate, or something, is related to time. Okay, good. That's a perfect example. What's another example? Let's see, any other, what else? Well, really simple, like the temperature, daily temperature is related to the season, right? Of course, right? So, if this season is summer, then in the northern hemisphere, it's warmer, right? Or you could do it in terms of the days of the year, or something like that. There's a relationship between the day of the year and the temperature, right? So what are the two things that we're relating there?
Temperature and time.
Time and temperature. Okay, what else?
You can relate anything with time.
What?
You can relate anything with time.
Lots of things are related to time. Let's skip out of time and think of another example. Yeah.
The more you teach your children, the cleverer they become.
Okay, great. Yeah, the more hours you spend with your children, maybe, or teaching them, or both, the better their academic performance will be. Right? Yeah. Might not be true, but I think it is true. But anyway, that's the sentence, right? It's relating what? Number of hours. It's time again, but anyway. And
Professor, the way you put it, it's time, but the way I put it is effort.
okay, effort. Okay, good, very good. So effort and
The word you used would be time.
something like aptitude. Okay, so these are, obviously we could go on and on, right? Now the interesting thing is that if you think about all the things that you study, you're almost always studying that kind of thing. You're almost always studying relationships between things. Like, okay, let's say you're studying marketing. Okay, so you might be studying the relationship between advertising and sales. Right? That's a very, of course you're going to be studying that in marketing. Or lots of it, in all of our studies, we're always studying, it's like, that's all we study is relationships. Right? Okay, so that's what a function is. It expresses a relationship between two things. Okay? And in mathematics, we kind of abstract that idea from any particular example, and we just study the idea of relationship or the idea of function, right? We don't have to think about that it's time or effort and intelligence, or it's time and temperature. We don't worry about the application of it. We just study the concept of function, and we try to learn things about functions. Then we can apply those things that we learned to all of these different examples, right? Right? So that's the point of mathematics, right? It kind of abstracts these things, and then you can use them in many different areas. Okay, so here's an example of a relationship. So this says, the following table gives the approximate number of Facebook users at various times since its establishment in 2004. So I guess Facebook started here. Now Facebook is in the news a lot recently. It's getting a lot of bad press. In fact, the president, Mark Zuckerberg, had to go in front of the US Senate yesterday, like about 12 hours ago, and he was tortured by them. Not literally. But I mean, he was, probably yelled and screamed at by them because they're very angry because he allowed all kinds of things to be done with people's personal data. Anyway, it's in the news. Anyway, it started in 2004. And I guess at 2004 there weren't any members. And then in so the 0 means 2004. And 1 means 2005. And 2 means 2006, and this goes up to 2010. And this row here is the number of users in millions. Okay, so after the first year, according to this, he had already 1 million users. And after the second year, it went here. And after the third year, it went up, and so on, all the way up to here. So here we see there are two things that are related. The top row and the bottom row. So in this case, the example is time, and the bottom is members, right? So this is a relationship, or we're going to call it a function. It's a function relates to variables, or is the expression of a relationship between two variables. And this is like the expression of the relationship. When time is 0, we can say what the members are. When time is 1, we can say. So given this, we can say what this is. So that means this is called a function. Okay? So now this row here is the time, and this row here is the number of members. And usually we refer to one of these as the input variable, and one of them as the output variable. So, but you could reverse it. You could say this is the input. It doesn't actually, you don't have to, but typically you would think of this as the input variable. And this, so you'd say when the input is 3, in other words, when the year is 2007, the output is 12, or 12 million. Okay? So this is an example of what we call a function. So the following table gives the approximate number of, okay, let's write, so n, t stands for time, and n stands for the number of users, okay? And this symbol means what was n when t is 0. So what was n when t was 0? Well, here's t is 0, and n was 0. So we would say n of 0, this is read n of. N of 0 is equal to 0. And n of 1 means what? How many users were there in year 1, right? Or year 2005. What's the answer? 1, or 1 million, right? So we would say n of 1 equals 1 million. Okay? And n of 2 equals what? 5.5. Right? So this n bracket 0 bracket is read n of 0. Okay? And n of 6 is 450. Okay? So this is notation for a function. Okay, this is a notation. Okay, in general we write n of t for the number of members in millions at time t. Right? N of 1, n of 2, n of 3, n of 4, and so on. We call n a function of the variable t. Okay? So the language is n is a function of the variable t, or going back to the actual meaning of n and t, the number of Facebook members is a function of the year. Right? The number of Facebook users is a function of the year, which sounds right? That sounds like proper explanation. Okay, so n is a function of the variable t, meaning that for each value of t between 0 and 6, n gives us a single corresponding number, n of t, the number of members at that time, okay? In general, we think of a function as a way of producing new objects from old ones. What does he mean by that? Well, here's the new object 3, here's the old object 3, and put in 3, we get out something else. Okay? All right, now let's take it away from this example, and let's say we have a function which expresses the relationship between guys and their girlfriends. Okay, so n, or let's call it G, for girlfriend. So the input is a particular guy, and the output is who his girlfriend is. Okay? All right, so you have a function called G, and you put in X, some guy, and you get out that. So what here is you have the different guys, and down here is you have their girlfriends. Or this could be, people and their fathers. Right? So that's a function also. Okay? It's just you have a relation between an input and the output. Okay? Now in math, we usually have inputs and outputs that are numbers. But the concept of function applies in any case. Okay? We can still say they're a function that relates people to their parents, or people to their father, or people to their parents, yeah. Okay? But usually in math we won't work on those examples, at least not in this class. We won't work on those examples. Okay, we'll be using numerical inputs and numerical outputs. Okay? So in general, we think of a function as a way of producing new objects from old ones. So the inputs are the old ones, and the outputs are the new ones. So the guy would be the old one, and the new one would be his girlfriend. The functions we deal with in this text produce new numbers from old numbers. The numbers we have in mind are real numbers, including not only positive and negative integers and fractions, but also numbers like this. So all kinds of numbers, any kinds of numbers, we're going to be working with those. Except complex numbers or imaginary numbers. We're not going to work with those in this course. Of course you could, and there are many courses that would, but we're not going to do that here. Here's a picture of that. So remember we had the number of members in Facebook. We put in the year, and this is supposed to be the function, and you get out the number of members. Okay? Okay, since we are using numbers as inputs and numbers as outputs, we say that our functions are this. So what does this mean? Real valued means what comes out of it is a real number. So, you know, in the example of boyfriend and girlfriend, we wouldn't say real valued, we'd say girlfriend valued. Because what comes out is the girlfriend. Okay? And so we'd say girlfriend valued functions of a boyfriend. So this is, in this sentence, or in this phrase, this is the input. So in our class, the input is going to be what? Not a boyfriend, but a real variable, a real number, right? And the output is not going to be a girlfriend, but it's going to be also a real number. So in math, the way they talk about this is they call it a real valued function. The value of the function means the output of the function. So that's just language that you have to learn. Okay? The value of the function means the output. Okay? I didn't make that up. It's just, you have to learn it. Okay? The value